So this was a weekly pop quiz which was related to rate and reversible reactions. Ammonia is made in an industrial process starting with nitrogen. The equation for this reaction is shown. N2 plus 3H2 gives 2NH3 and the forward reaction is exothermic. State the effect, if any, on position of equilibrium when following changes are made. The reaction is exothermic and we are decreasing a temperature. We reduce the temperature. So what is the effect of reducing a temperature for exothermic reaction? Reducing a temperature, it will shift the equilibrium towards the right-hand side because the forward reaction is exothermic. So exothermic reactions, whenever you have an exothermic reaction and you reduce the temperature, that the balance or the equilibrium will always shift towards, no, there will be change. It will shift towards right.
Then said it's a forward.
Yeah, so forward reaction is exothermic, means the reaction is giving out energy. You have the reactant and you have the product. So exothermic reaction means the reactants have high energy and the product is having low energy. So we have both reactant product, and what we are doing, we are reducing a temperature. We decrease the temperature. So when we decrease the temperature, so we have both reactant, because in a reversible reaction, we have both reactant and we have product. We are reducing a temperature means we are removing the energy from them. Product is already having low energy. But when the reactant lose energy, they will form a product. So when the reactant start to form a product, where the equilibrium or the balance will shift, the equilibrium or the balance will shift towards the right-hand side. So the shift equilibrium towards the right-hand side as a forward reaction is exothermic. Then what is the effect of the pressure? Remember, if we increase the pressure, equilibrium will shift towards side of less moles of the gas. And if we decrease the pressure, equilibrium will shift towards side of more moles of the gas. When we check the moles of a gas, here we have 1 mole of nitrogen and 3 moles of hydrogen, so total 4 moles. Here we have 2 moles. So what we are doing, we are reducing the pressure. If we reduce the pressure or decrease the pressure, equilibrium or the balance will shift towards side of more moles. So which side we have more moles? We have the reactant side, we have more moles, or left side we have more moles. So where the equilibrium will shift, it will shift towards left. And because the answer here is decrease in pressure, shift the equilibrium or the balance towards the side of more moles. So that is what happened, how the pressure affects the equilibrium. Today we'll do an exercise as well. The whole exercise will be related to reversible reaction. So you will have a better understanding of reversible reaction as well. Explain in terms of particle what happened to a rate of a reaction when temperature is reduced. So here we are decreasing a temperature. So when we decrease the temperature, first thing what happened, energy will decrease. If energy decrease, what happened to the speed of the particles? Speed at which the particles are moving, that will also decrease. If the speed of the particle decrease, what happened to a number of the collision or the collision frequency, number of collision per second? The collision frequency will decrease, like few collisions every second. And there will be few particles have energy more than activation. And if few particles have energy more than activation, what will happen? The rate will decrease or the reaction rate will slow down. Rate of a reaction will decrease. So this was a pop quiz which was related to rate and the reversible reactions.